All right. Yeah, I kind of was crashing and burning on this one, thinking, what do you do on this? Well, what's important here is the height of this. And this is 8, but I had my x and my 8 minus x in the kind of backwards. Well, I guess I could keep them there, but I'm going to go like this and like this. Okay? All right. So, the height of this rectangle all depends upon the slope of this line going on here. The slope of the line, the rise over the run, it rises 10, runs to the right 8, or 5/4. So this y value will depend on the slope of the line. Okay? So it's 5/4 times how far we go over in the x direction. So it's 5/4 x. So this point here, y will equal 5/4 x. So that'll be the height the whole time, 5/4 x. And how far we are away from the start will be x. So this distance on this one, this would be x. And then this whole thing is 8. And the height of this would be 5/4 x. Okay? Now, we're looking for the perimeter. The perimeter is 2x plus 2 times y. The y value is 5/4 x. Okay? Now, the perimeter is not 2x, Mr. Bierschbach, you idiot. X is how far away you are from A. 8 minus x is how wide this is. And 5/4 x is how tall it is. Okay, so the perimeter would be 16 minus 2x plus 10/4 or 5/2 x. So the perimeter would be 16 minus 2x plus 5/2 is, this is 2.5, 16 plus 0.5 x. Okay, that's a perimeter. So, if we take the first derivative of the perimeter, it equals 0.5. Okay, that's the first derivative of the perimeter. Now, if we set that equal to 0, because to find the critical number, you set the first derivative equal to 0. What do I got going here? I got something that does not work. Okay? So this one is actually, there is no such rectangle here. Okay? There is no such rectangle when we deal with the perimeters. Now, areas is a different story. Perimeters is not. Because the perimeter, the way it changes, there's no perimeter of a rectangle that would minimize the rectangle's perimeter. Okay? That one's a little different one. Okay? So if you hit that one, that's how you go about it. Okay? Now let's do one with area. Same problem, but area. So this is 10, this is 8, so this is x, how far it is away. So this would be 8 minus x. And this is y, which the height of it is 5/4 x from the last problem. Okay? So area of a rectangle is the base times the height, or in this case, it's 8 minus x times 5/4 x. So the area is 5/4 times 8 is 10x minus 5/4 x squared. So what's next? Now that I got the area function, I find because to find the maximum or minimum area, I do the first derivative. 10 minus 10/4 x. Set equals 0. So 10 equals, and 10/4 is really 5/2. So move the 10/4 to the other side. Multiply by 2/5. X is equal to what? 2/5 of 10 is 4. So if this is 4, this is 5. So the largest rectangle area-wise would be 20. Now, if we want to check and see if that makes any sense, let's just make this 3. Okay, if this is 3, or if x is 3, then 8 minus x would be 5, and 5/4 of 3 would be 15/4. If we take 15/4 times 5, which would be 75/4, okay, for the area, 75/4 is less than 20, correct? So that would be a smaller area if you went down in size for x. So let's make x a little larger. Let's make x 5. If we make x 5, then this becomes 3, and this becomes 5/4 times 5, or 25/4, times 3 is, again, 75/4, which is less than 20. So, obviously, 20 would be the biggest area. All right. Positive numbers, x and a minus x, have a sum of a, because if you add these up, you get a. What is x in terms of a if their product is a maximum? Okay, what is x in terms of a if their product is a maximum? So on this one, what we have to do, their product is x times a minus x. So their product is ax minus x squared. So then we take the first derivative of the product, a minus 2x equals 0. It says, what is x in terms of a? Okay, we want to know what x equals. So a equals 2x, divide by 2. X must equal 1/2 a. So 1/2 a would be the answer. Okay, no numbers involved in that one. But actually, without numbers, it actually made it a little simpler. What is the maximum vertical distance between the curves this and this? Somewhere in between here. Okay? So the maximum vertical distance is the difference of their y values. Okay? So the cosine curve might be going like this, while the sine curve's going like this. We want to find the difference of their y values. So at some particular x, there's a difference in the y values. When I say the word difference in math, what does that mean? Subtraction. So my y is going to be 2 cosine of x minus sine of 2x. Okay, that's going to be my difference in those two, because difference means we subtract. Okay, now when I take my first derivative of this, what's the first derivative of 2 cosine of x? -2 sine of x. What's the first derivative of negative sine of 2x? Negative cosine of 2x times 2. And we set that equal to 0. Okay? Set that equal to 0. Now, the cosine of 2x from trigonometry class, because I want to get these into one term, from trig class, cosine of 2x is cosine squared of x minus sine squared of x, or it's 2 cosine squared of x minus 1, or it's 1 minus 2 sine squared of x. by doing it this way, then everything's in terms of sign. So if we distribute the negative 2 through, I get negative 2 sine of x minus 2 plus 4 sine squared of x. Okay? Will this factor? Yeah. If I take out a 2, I get 2 sine squared of x minus sine of x minus 1. So it's 2 sine of x plus 1 times sine of x minus 1. Okay? Because if I do that, if I FOIL, 2 sine squared, outers is minus 2 sine of x, inners is plus 1 sine of x to make negative sine of x, and then minus 1. So 2 sine of x plus 1 equals 0. Sine of x minus 1 equals 0. So 2 sine of x equals negative 1, and sine of x equals 1. So sine of x equals negative 1/2. Now it said where we're at. We're somewhere in between negative pi over 2 and pi over 4. If sine of x equals, where does sine of x equal negative 1/2? Where does sine of x equal negative 1/2 on the unit circle? At 11 pi over 6, there's one other. 7 pi over 6, there you go. Where is the sine of x equal 1 at? Pi over 2. So, which of those is in between negative pi over 2 and pi over 4? Well, 11 pi over 6 is the same as negative pi over 6. 7 pi over 6 is the same as negative 5 pi over 6. So the only one that is in that realm is negative pi over 6. Okay, almost done. Okay, here's a function where the height is the y value of this. The height is the y value. If x is right here, there's x here, and then there's x here. Okay? So, if we're talking about area of a triangle is 1/2 the base times the height. What's the length of this base? 2x. So it's 1/2 of 2x, and the height is the value of the function, because this is the y value, how far up you are from the x-axis. That's the height, 9 minus x squared. Okay? So, if we're finding the area of that, 1/2 and 2 cancel. If we distribute the x, it's 9x minus x cubed. That's the area of this. So, to find the maximum, take the first derivative, 9 minus 3x squared. So that equals 0. 9 equals 3x squared. Divide by 3. X squared equals 3. Take the square root. X equals the square root of 3. Okay? So what is the area of this triangle? We take the square root of 3 is this. The square root of 3 is this. We plug the square root of 3 into here. 9 minus the square root of 3 squared, or 9 minus 3, is 6. So it's 2 square root of 3 times 1/2 times 6. Well, these cancel. So it's 6 square root of 3. So these optimization problems get a little bit difficult on how you exactly set them up, but you set them up, find the first derivative, set the first derivative equal to 0, and then you should find your answer. Okay? So there you go. You got until Tuesday to get these done. Then on Tuesday, we'll have a fairly short lesson before lunch. After lunch, we'll review for the Khan Academy test. Then you have some time to take the Khan Academy test, and then we'll review for the AP Classroom test, and that's the semester.